to take a peek at number 40 and 47 from the homework yesterday, just so you can kind of see, because sometimes I know we don't do a whole lot with some application things and really thinking about why we do some of the things that we do. So on 40 and 41, I'm going to talk about 40. It talks about before we graphed absolute value functions. We did that in Unit 1. And now we're doing this stuff. So what we're supposed to do is we're supposed to graph both of these on a single grid and then look for things that are similar and different between the two so we can kind of start making a connection. And we did a little bit of this yesterday. So maybe even do this one along on your homework sheet, kind of get you out of having to do a couple of them here. So I look at this first one and I go, okay, my first thing is I need to find the vertex. Well, it's already in a form where I can find the vertex pretty easy. What's my vertex going to be on the absolute value equation? I think I heard it. 2, 1. Okay. Opposite. Keep it. Okay. So I go to 2, 1. Put a dot. Now with absolute value graphs, this is where things change a little bit. That value in front of my absolute value, the -1, that's my, again, air quote, slope, which means I'm going to be going down. So I go down 1 and over 1 each direction. And I do that a couple of times on each one. So I do the down, left, and right, because again, the negative's just telling me that it's opening downward. And again, my absolute value graphs look like V's. They go straight line. So then we get into a little bit of what we were doing yesterday. So we're like, okay, what's my vertex on my quadratic? Yeah, here's our first similarity. The vertex is the same. I'm starting at the exact same place. But here's where it's different. The negative tells me that it's opening down, but it doesn't quite work the same as slope does, or our air quote slope did. So we chatted a little bit yesterday about the need to maybe have the calculator help us out some. So I'm going to go ahead and type this in. Again, make sure you don't forget that negative in front, because that'd make things a little not too hot. I always like to look at my graph because it lets me know if it kind of looks correct, and it does. My vertex is just above the axis, okay. And then we talked about getting my vertex in the middle because I see the symmetry that's around it. So I start plotting some of the other points. So I'm like, okay, 1, 0. Hey, that's still like the same point. 3, 0. Is this going to be like the same graph? That'd be kind of weird. Let's see what else we got here. 4, -3. Okay, now we're changing some. 0, -3. And we always say 5 points will kind of get us to what we're looking for. Now, two expressions that look pretty similar. Their graphs look pretty similar. But what is it that makes them different? Well, they have the same vertex. Okay, we noticed that. That's a similarity. They both open down, and these are the type things I want you thinking about on these, because if you make connections like this, it makes everything kind of blend together and be a little bit easier to work with. But the difference is, my parabola doesn't use slope. There's a different thing to when I'm dealing with a parabola. It grows what's called exponentially. This grows linear. It's the same amount. It's always down 1 over 1, down 1 over 1, or whatever that value is. But with a parabola, that value gets bigger as it gets wider and starts to get wider and wider. And that's kind of the connection that we're trying to make here. So you've got 41 that'll kind of look similar, but you'll be able to see some different things in that. So I'll let you do that one. Now the other one we're going to take a peek at, and then get back into some normal graphing, is 47, because I had a couple of you ask me about this yesterday. Now 47 talks about a couple of things that I'm going to make mention of here at the very start. It says, you can find the rate of change. There's another word we use for rate of change a lot around here, and sometimes we don't use rate of change enough so we understand what that means. Rate of change is just like your slope. Okay? So you can find the rate of change, find the slope for an interval between 2 points of a function by finding the slope between the points. Use the graph to find the y value for each x value, then find the rate of change. So basically, what we're looking at here, and let me get the points plotted on this so it's a little bit easier for us to see. Because yours and the book's already done for you. Okay, so in your book, you basically see this. So, what I do is I'm going to work my way through this and say, okay, so when x is 0, okay, y is 10, when x is 1, y is 9, so I can fill in both of those. And basically, I'm just going up to see what's the y value when I get to the graph. And it looks like we're at 1. Okay, once I get those values plugged in, my job becomes to find the slope. Now I have to remember how to find slope. That's kind of important. So when I'm doing that, just a reminder, thank you, is when I'm doing that, slope is the difference of my y's over the difference of my x's. But again, I have to take them in the same order. So if I did 10 minus 9, I've got to do 0 minus 1. And whatever that ends up being, 1 over negative 1, would be my rate of change, my slope. Now the interesting thing here would be, if it were an absolute value, it would be that for the rest of them. But we're going to find out that's not the case with these. So if I do it again on the next one, subtract my y's over, subtract my x's, I get 3 over negative 1. And I'm starting to wonder if maybe there's a pattern developing here. So let's do this last one and see if we can maybe see that. Okay, 6 minus 1. 2 minus 3, 6 minus 1 is 5 over negative 1. Would anybody care to guess, if I did have a letter D with the next 2 points that were there, what the rate of change might be? Negative 1, negative 3, negative 5. What do you think would come next if I kept going? Negative 7. Okay? So what I'm trying to kind of see here, because it asks, what did you notice about the rate of change as it gets further away from the vertex? Well, you can notice a couple of things. Okay. The slope gets steeper because the number gets bigger and bigger and bigger as I go along. And it also seems that the slope changes by 2 each time it keeps going. Negative 1, negative 3, negative 5. If I kept going, maybe it goes to negative 7, negative 9. And I can start seeing that. Maybe, just maybe if I start seeing that pattern regularly, I don't have to use the calculator anymore for this. I can start just using the pattern to graph these. Because I'll let you in on a secret. If it's just parentheses and x plus or minus something, that actually is the pattern that you can use. So you wouldn't necessarily have to go to the graph. So watch that when we're graphing them today and see if you can see that same pattern. But that's why these questions are so important. And when we do them on reviews and when I'm looking at homework checks and these get skipped, why I circle them and mark them and don't give you full credit. This is where we start to kind of make connections with things a little bit besides just, Harty's telling me to graph this somewhere, whoop-de-doo. My slope gets steeper each time because this value is going up. And then the slope is changing by 2 each time. I was looking for patterns in this. And those were the 2 patterns that jumped out at me right away with this one. Now, sometimes you may see different patterns. You may not see much of a pattern at all. But try to start finding those because that makes math a whole lot easier in a lot of ways is, can I find this particular pattern that's involved? Now, we're going to roll that straight into a quick review of yesterday, and then we're just going to get you to the assignment, which is the worksheet today, and I got a couple of hints for you on it too. So, okay, right now we're graphing in vertex form. We just talked about that on those couple of problems that we did. So reminders when we're doing this. Okay? The h and the k that I can get from there form my vertex. But again, I always got to remember h is the opposite when I'm doing in here. So if I see plus h in here, it means I'm going left. If I see minus h in here, it means I'm going to the right. That k value on the outside is my up and my down. So if it's plus k, we go up. If it's minus k, we go down. So those things will tell me right away how I can get to my vertex pretty easy because they're just some of the shifts. And then the one other thing we've also noticed is what direction does my parabola go? If there's a positive value in front, even if it's just 1, that opens up. If it's negative, it's going to open down. So we can get a lot of information just from there before we even start doing the graphing. And then the axis of symmetry, my x equals, just a reminder from yesterday, is the x value of the vertex. So if I know the vertex, I know the axis of symmetry because they're one and the same. So this kind of is going to let us kind of go back over what we did yesterday. Try to simplify a few things here. We'll see how this goes. Just scooch that enough that we can get to this first part. Okay, so down here below, I want to know a few things because, again, it helps us to get some practice at some stuff that maybe we missed yesterday or maybe, we just need a quick review of. So first things first, what's my vertex in example 1? Okay, 2, negative 3. The opposite of h, opposite of negative 2 is 2, negative 3. So 2, negative 3. Now, here's where I can choose to do this next part in a couple different ways. Okay, the transformations I can either take from the expression, or if I've already plotted my vertex, I can just do the counting. How do I get from the origin to here? Which would be like, well, I go right 2, and I go down 3. So I can do it from the graph, starting from the origin, or I can use the formula. Negative inside means I'm going right, so right 2. Negative on the outside means I'm going down, down 3. They both work. And then my axis of symmetry comes directly from my vertex. And that's basically it for the informational type things we do. But now we get to take that peek at the graph, and maybe we start to see the patterns that we were talking about before. So again, if you haven't done one of these before, or maybe yesterday you're kind of like, just watch. Again, y equals to get to here, clear out anything that's there, and we're going to type in plot the expression. So we've got x minus 2 squared minus 3. Looks good. Okay, I always, again, hit graph before I go to the table just to make sure that my vertex looks like it's in the same spot that I put it. If they look different, something didn't work right. And then to get the table, I just hit second and graph. And I want my vertex in the middle, which it is. Because again, I see symmetry then. I see the same thing above and below that. And I can start plotting the points. So let's do that. And once we plot these, let me get this a little bit bigger here because I know sometimes that graph can be kind of tough to see. Oh, it especially can be tough to see when it goes out of focus. Ooh. Oh. Okay. So, let's see here. So we've got 1, oh, Harty. Yeah, that's right. 1, -2, 0, 1, 4, 1. And I can keep going if I want to. And actually, I'm going to this time. Now, you remember when we were talking about that pattern in the other one, where it went 1, then it went 3, then it went 5 with the slope. Let's see if that happened on this one. So if I start here, I went up 1 and over 1. Okay, that'd be a slope of 1. So how do I get to the next dot? Up 1, 2, 3, and over 1. Ooh, that is kind of working. 1, 2, 3, 4, 5 over 1. So you start to see, I don't even really need the calculator to do this. If there's no number in front of the parentheses, the 1, 3, 5 pattern, just using that kind of air quote slope, can get me my value. Now, does it mean I can't use the calculator? No, it doesn't. But if you're in a situation sometime where you don't have one, it doesn't mean that you can't do it. So, not a bad little tidbit to know. So then, let's shift over here. Now, this one, a little different. Okay, my vertex is still going to be found the same way. What's my vertex for example 2? -3 and 6. Again, opposite of 3 is -3. Keep the 1 out there. So -3, 6. Okay, what are my transformations? What are my shifts? All right, left 3 and up 6. And again, from here or from knowing, I went left 3 and up 6 to make my vertex. So let's see if we plug this one in, and I notice a couple of things. I notice it's a -a value, which tells me this is going to be opening down, so I have a couple of clues to let me know what's going on here. Okay, type everything in right, looks good. Look at my graph, it opens down, that's good, and it looks like my vertex is in about the right spot. So I'm feeling good with this. So let me get my chart up. Got to get my -3, 6 in the middle so I see my symmetry. So let's plot some other points here, and maybe, just maybe, we can find another pattern to make this easier on us. Oof, that's going to be right off my graph. Well, let's put it on here anyway. And again, I'm trying to get a little bit of curve in here. Sometimes that's hard, but at least we try to give it a good effort that way. So once I get that in, again, instead of just moving on, let's ponder this for a minute. Okay, so before our pattern, let me get the calculator out of the way here. Our pattern on slope was 1, then 3, then 5. Now let's see what it is this time. 1, 2, and over 1. Okay, so 2. 1, 2, 3, 4, 5, 6, and over 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and over 1. 1 times what gets me to 2? 2. 3 times 2 gets me to 6. 5 times 2 gets me to 10. The pattern's the same, except if there's a number in front, you multiply the 1, 3, 5 by those to keep making your dots. And again, if that's an aha moment for you and you're like, oh, I can whip through these now, great. If not, keep playing with the calculator for now, and maybe the pattern becomes more clear to you a little bit later. But that's something you can do. And my axis of symmetry is still the x value of my vertex. That's basically what we did yesterday and what we're doing again today. So here's how we're going to apply it. The practice sheet that you just got, which I just realized something that I will get to momentarily. I didn't put any graph paper out. That wasn't very smart. So I'll get that out in just a second. For 1, 2, and 3, we're just going to be graphing them, just like we just got done doing. For 4 through 9, notice, okay, how is each a translation? What are the shifts? No graphing. Just write down up, down, left, right, whatever's happening to that graph or wood, you're going to write down what the shifts are. Now, one thing we didn't talk about just now in the review, and I'll talk about it here. Okay, graph. What's the vertex? Okay. What's the axis of symmetry? Okay. The maximum or minimum value. Now let's chat here. When we're talking about a maximum or a minimum value, okay, we're talking about the vertex's y value. So for instance, we'll go ahead and we'll get this put on one of your examples here. So I'm going to kind of put that back up. If I was looking at example 1, since it opens up, my vertex is at the bottom. That would be a minimum. Okay, bottom is minimum. You're kind of at the bottom of things, whatever it is. That kind of makes sense. And my minimum value is whatever the y value of my vertex is. Axis of symmetry for x, min or max, okay, is going to be my y. And it would be the same thing on example 2. This time, my vertex is at the top. So it's a maximum value. Bottom, minimum, top, maximum. That makes sense. And again, it's just the y value that I'm looking at. So you can get a lot of information, and we're going to do some application stuff here coming up early next week with this, maybe a little bit today even, that lets you start to see where this actually has some use. Okay, so that gets us max and min, okay. Oh, the domain and range. All right, one more referral. Woo, we can get a lot of information off one of these things. Okay, we did talk about this yesterday. Domain, same every time on a parabola. This goes out forever to the left. This goes out forever to the right. That doesn't change. That should be the easiest question on any quiz or test I ever give you. The range I have to watch, though. Okay. Remember, range is my y values going from the bottom to the top. Does this parabola in 1 go down forever? No. -3. But it does go up forever. And I think the same thing on example 2. Again, domain, easiest question on earth. Range, ooh, now be careful this time. Does it go down forever? Nice. It goes down forever, but it doesn't go up forever. It hits its peak at the maximum. Oh, another connection. Check that out. If you know your max or your min, you know the bottom or the top of your range. They all interconnect. So again, keep that handy when you're doing this because, again, it'll give you a nice reference point. Okay, so we got that figured out. Let's see here. What else we got? Okay. When we get to the back, here comes an application. I'll do one with you. What quadratic function models each graph? In other words, what's the equation? You're like, what? You want me to make the equation? Yeah. Okay. How am I going to do this? I need to find the vertex and the slope and plug them in. Let's do this. So I look and I go, okay, let's see, my vertex. Here's my vertex right there. So let's see, what value is that? 1, 2, 3, 4, 5. Okay, 1, 5. There's my h and my k to plug in. And it says the other thing I need to know is my slope. Okay. Because I've given you that first point when you're going through these. So let's see here. 1, 2, 3, 4, 1. My a value is 4. Or I could say 4 over 1. That's not a bad thing. Okay. If you can see other points, you can use them. And I'm actually going to do 14 with you too because it threw a twist in that I don't like. So here we go. Y equals A, because I'm just plugging in the 3 values that I have, X minus H. Notice how it becomes the opposite, plus K. I made the equation. So all I'm really doing on this is I work through them. Is I'm finding my vertex. So let's see, here it's at -3, -2. Now, here's where life gets a little more interesting. This one's a little trickier, and here's why. I want to go to the dot. I really do. But I start looking, I'm like, well, hey, those are going through, and that would be my 1, you know, I can keep going. Do I have to go to the dot they give me? I would, just because in this case, that's going to make life a little easier, so that's what we're going to do. 1, 2, 3, ooh, 1, 2. That's weird. Can it actually be a fraction sometimes? It can. Once I get there, I'm ready to go. So y equals, my a is negative because it's opening down. X, be careful, minus -3, or x, the opposite of h, makes that plus. And then the -2. Okay, and I'm done. In the other 2 problems here on the back, because now you've got a good example to be able to knock out 15 on your own. Okay, error analysis. Classmate has said the vertex was this. They wrote it down. What mistake did they make? What's the right one? You can handle that. And then I got a challenge for you. But I also have a hint. You're like, whoa, what is that? You're giving me like lots of numbers in places, Harty. How does this work? Okay, here's how this one works. This one is like problem 5 on page 198. You're like, wait, you want me to look in the book to see an example? I do. Because it will get you all of the information that you need. Now, here's what I will do to help. I'm going to give you some of the points that you may need to make this work. But I'm going to make you look at the example that's done in the book to try and figure out how to write this and how to make the equation out of it. And I've given some hints. What's the vertex? What's the slope? Plug them in. It's a lot like what we did in 13 to 15, but I want you to work at this a little bit. So you've got some time today. Tomorrow we're going to expand a little. We're going to get one more form of the quadratics in. But again, keys are always up here. We'll hit some review. And as you may have noticed up front, the quiz has been moved back a little bit because I want to spend a little more time on some of this stuff. So